What's up, guys? This is Aditya from Titan Coding, and in this course, you will learn how to program in Python in under 2 hours. Before we get started, you will need to install Python from python.org, and you'll need a text editor, and I'll be using Visual Studio Code. So let's get started.
I have opened up my text editor, which is Visual Studio Code, and we are going to open a folder. So we will click Open Folder, then we will choose what file or folder we want, and then I'm choosing Python projects as my folder, and then click Open. And if you don't have a folder made, you can create a new folder. Then we're going to click this icon right here, which is the top icon, and then we will see Python projects or the file name up here. And then we're going to click the first icon, which will create a new file, and we'll name it whatever we want. So I'm going to name it project 1. And then we have to add the .py, which tells the computer that this is the Python file. Hit enter, and then we have our Python file. So now, to print something in Python, we want to type up print, parentheses, then quotation marks, and then type up what we want to print. So we are going to type hello world. So now that we have our code written, we're going to save it. To save it, we're going to use the keyboard shortcut called Command S for Mac and Control S for Windows users. So I'm on a Mac, so we're going to be using Command S. And then to open the terminal on Mac, you're going to click Terminal up here, click New Terminal, and then you're going to get the terminal down here. On Windows, I'm not really sure, but you can you find a terminal like the standard computer terminal and use that. So then you're gonna pull it up to this folder and enter to the folder, which is Python projects. And then to run the code, we're gonna type up Python project1.py, and project1 is the file name. So we will type up the file name to run the file. And when we run it, we see hello world.
So now that you've learned how to print stuff in Python, we're now going to learn about variables and data types. So let's get started.
So I've created the file, and now we're going to talk about what are data types. So a data type is like a type of data, like a number, a word, or a letter. In Python, data are classified differently. So in Python, the first data type is a string, which is like hello coding, and anything that is surrounded by quotations will be classified as a string in Python. So a string must have quotations. Now let's talk about integers. So an integer, 10, 15, and like 22. So it's like a number that does not have a decimal point value and is not surrounded by quotations. That's what an integer is. Now let's talk about what floats are. So a float is like 10.5, 15.3, and like 22.7. So that's what floats are. So a float is any number that has a decimal point value and that is not surrounded by quotations. So if it is surrounded by quotations, then it'll become a string. So now let's talk about Boolean values. So a Boolean value is like true or false. So a Boolean value can only be true or false, nothing else. Now I'm going to write down some data, and you guys are going to pause the video and guess what kind of data type they are. So let's say 10. So I want you guys to pause the video and guess what kind of data type each of these data are. So I'm glad that you guys have guessed, and now I'll tell you the answers. So 10 is an integer because it is a whole number without a decimal point value, and it's not surrounded by quotations. Now, this 10 is surrounded by quotations, so it is a string. Now, hello is also a string because it's a word and it's surrounded by quotations. True is a Boolean value because a Boolean value is true or false. 15.3 is a float value because it has a decimal point value and it does not have quotations around the data. And then 15.5 is a string because it has quotations around the data, which is 15.5. So now let's talk about variables. So to define a variable in Python is very simple. All you're going to do is type in your variable name. So let's take a variable name as age. And we'll set it equal to 25. And to print a variable, we're going to use the print function like we have learned in the previous video. And we're going to print the variable name, which is age. So now we're going to save our file and open up our terminal. And we're going to run the command python 3 variables.py and hit enter. And it prints us 25. So now let's assign another value to age. We'll say age equals 30. And then we're going to print age again and save it. And we will run the same command. It's going to print 25 and then 30. The reason behind this is because here age is 25. So we print age and age is 25 here. And then the computer sees that age became 30. So when we print age again, it says 30. And that applies to all data types. It'll print the latest update to that variable.
Next, we're going to learn about basic operators and input.
So to get input from the person who's using this code, we're going to type up the keyword input with the parentheses. But we need to store our input in a variable. So we can just say color equals input. And then to ask the user a question, we're going to have quotations and type up our question that the computer should show to the user. So we're going to type up, what is your favorite color? So we're going to ask the user what is their favorite color and store it in the color variable. And then we'll just say print color. So this will print whatever the user puts in as their favorite color. So let us save our file and run our file now. So our file is python 3 input.py. Hit enter. What is your favorite color? It says down here. So my favorite color is blue. When I hit enter, it's going to print blue because the logic behind this is it gets the input from the user and we enter blue and then it says color equals blue and then we print color, which is blue. Now let's talk about basic operators. So there are four main operators, which is plus, minus, multiplication, and dividing operators. So each operator has a purpose. So plus is obviously to add, minus is subtract, the star or asterisk is for multiplication, and the slash is for division. And then there is two asterisks, which is used for exponents, and there is slash slash, which is used for integer division. So integer division is like 64 divided by 10 would equal usually 6.4, right? But when we add the second slash, it doesn't care about the remainder and just says 6, because it usually would be 6, the remainder 4, and it just rounds it to 6 because it does not care about the remainder. And then exponents would be like 10 asterisk asterisk 2, which would equal 100 because 10 to the second power is 100. So now let's combine that with what we learned in the previous video and use them on some variables. So we can just say num1 equals 10. Then we'll say num2 equals 15. And then what we will do is we can take num1 plus num2, and we can store it in the variable of sum. But we have run into a problem because sum is a keyword. So we can use capital sum because in Python you can have a capital of the same word, but it would be a completely different variable. So we'll say capital sum equals num1 plus num2. Let us print sum. Now let's save it and run our code, and it prints 25 because 10 plus 15 equals 25. And we can also use this for subtraction, and when we run it, it'll print -5 because 10 minus 15 is -5. And it also works with multiplication, division, and I'll just show you with exponents. So 10 to the 15th power is a really large number, and then we can also do slash slash, and we can swap these around. So 15 divided by 10. Let's run it. It'll only run as 1 because it would have a remainder of 5, but divide or slash slash, which is integer division, doesn't care about the remainder. And then now let's talk about another variable, or not variable, but operator, which is modulus, which is the percent sign. So it'll be num1 modulus %2. So num1 is 15, which is divided by 10, and the modulus operator returns the remainder. So in this case, num1 divided by num2 would be 1, but there would be a remainder of 5. So num1 modulus num2 would be 5. Let's print sum. Here, let's run the code, and it returns 5. And then, now let's use some input functions. So let's say num1 equals input first number. And then we can do num2 equals input second number. So now we're going to get the input of two numbers, and we're going to save it in the sum variable, which should be num1 plus num2, and then we can print sum. So this is like a simple one operator calculator. So we can say first number equals 5 down here. Second number we could say 10. And then we get 510. But the problem is actually because we have to change the type of this. Because when you get input from the computer or like a user and sends it into the computer as num2, it stores it as a string. So we have to change this to an integer because you cannot add strings. Like when you add strings, it'll be 5 plus 10, right? So it'll be 5, 10. So it'll be 5, 1, 0 or 5, 10. So here we can use the int and typecast each of these variables. So this will convert them to an integer. So we can save this now and run it again. We'll say 10 and then 15. And when we run it, we get 25. So this also works with like slash slash, which is integer division. We can run this and we'll say 64. And then we can say 10 and we will get 6.
So now that you've learned about the basic operators and input, we're now going to learn about conditionals.
So a conditional is like a statement that returns a true or false value. So like in this case, 10 is greater than 9. So 10 is greater than 9 will return true. And then another example of this would be 10 is equal to 10. And you would think this equals to true, right? But this actually does not, because in Python, you need to have two equal sign when you're comparing values. So if you have one equal sign, the computer will think that you're trying to create a variable called 10 and set the value to 10. And that is not possible. So here we would have to have two equal signs. And then 10 equals to 10 is true. And then we can also have 10 exclamation mark equals to 10, which means not equals. And that would be false. So that's the basics of conditionals. So now, how do we use that? So I'm gonna write a print statement. So we can do print 10 is greater than 11. And this should return false. So I'm gonna save it and open up my terminal, which is also my console. And I'm gonna type in Python 3 conditionals.py and hit enter. And it returns false. So this is a false statement because 10 is actually less than 11. And let's say 10 is greater than 9 and save it and run the program, it returns true. So now I'm going to quiz you guys here. I'm going to do a couple of print statements. And I'm going to ask you guys to guess. So now I want you guys to guess what each of these print statements will print. Okay? So now please pause the video and guess. So hopefully that you have guessed now. Let us run the code. And here we see the top statement is false here because 15 does equal 15, and we're saying 15 does not equal to 15. The second one is also false because 10 is actually less than 11 when we're saying that 10 is greater than 11. And then the final one is true because 10 is actually greater than 9, and we're saying 10 is greater than 9.
So now that you've learned about conditionals, we are now going to learn about the if, elif, and else statements. So let's get started.
So first, let's talk about the syntax. So in Python, an if statement is wrote as if, Then you have the condition here, and then you have a colon. And then you hit enter, and there should be an indent here. So that the code you write will only be run inside the if statement. So now, let's get into basic if statements. So I'll say if 8 is greater than 2, then put a colon, and then we can say print 8 is greater than 2. And let's save it, Command S. And then we're gonna open up our terminal here. And then once this opens up, we're gonna type in Python 3 if statements.py and hit enter is to run code only if a condition is true. So it'll only run the print statement here if 8 is greater than 2. So let's say 8 is less than 2 here. Quickly pause the video and guess what you think will happen. Okay, so now let's run the code, and it doesn't print anything because this is a false condition. So it does not run the code inside of the if statement. So now let's use input and if statements together. So I'm gonna create like age as a variable equals input. Then we can say what is your age, and then we can put a colon here, and then we can put if age is greater than or equal to 18, then we can put a colon and say print you are an adult. But it's not done yet because you can only compare integers using these greater than or equal to operators. So what we have to do is we can convert age to a integer. We can say age equals age and wrap it in an int converting. So now let's save this and run it and hit enter. So what is your age? We'll say 19. Let's give it a second. Okay, hit enter. And it says you're an adult because you're 19. Now let's talk about elif statements. So elif is like an if statement, but it'll only run if the previous if statement or elif statement was false. So let's say I run if here, and it's true, it won't go through the elif. But if I wrote if age is greater than or equal to 18, and it was false, and I wrote if age is less than or equal to 18, it would run both of them. So elif is to only run one if it's true, and it will stop running all of these if statements if one of them turns out to be true. So elif here will say that age is less than 18 here. So age is less than or equal to 18 here, colon, and then print you are not an adult, and put quotations. And let's save that. Command S. Okay. Now we're going to run this. And I'll say, what's your age? We'll say 18. And also here, let's quickly put this to just less than. Save this. Okay. So now, for input, 18. It says you're not an adult. And let's say we run the code again, and we say 19. It says you are an adult. But in this situation here, we had 19. So it runs this first if statement, and it says, oh, it's true. And then the computer thinks, oh, that means I don't need to run this elif statement. That's the use of elif statements. And then we can say else print nothing, because we don't have an else here. But if we add, let's say, less than 18, and and here age is greater than 10, you can say that you're a kid, right? You're not an adult. And then you can say else print you are a child. So this will run if both the elif and if are false. So let's run this. And let's say 5. It says you are a child. That's what else statements are for, to run if all of the other ones, like other if statements and elif statements, are false. So now I'm going to make a project with you guys, and you guys probably want to follow along because I'm going to make a calculator. So we can say, we can take an input. So num1 equals input first number. Okay, save that. And then we can hit enter. And then we can say num2 equals input second number. And then we can take an operator like plus, minus, divide, or multiply. So we can say operator op equals input operator. Okay. And then what we're going to do here is, since these are going to be numbers, what we can do is we can say, put it int here, so it'll automatically convert it to an integer here. So here, int. So basically typecasting it in the input here. So let us have that then. Now we're going to get to the if statements. So we can say if op is equals to plus, but we have to have quotations because these both op and the plus are both strings. We can put colon, then we can say print num1 plus num2. And then we're going to hit enter. And by the way, if you haven't checked out my input and variables and conditional videos, those will all be linked down below. So now let's say elif, because if it's not plus, only then you're going to need to run this. So we can say elif op equals minus. Put a colon here, and we can print num1 minus num2. Hit enter. Then we can do elif op equals, we don't need parentheses here. We can say elif op equals asterisk, because in Python, asterisk is the way you multiply. You can put a colon, you can say print num1 times num2. Then we can do elif finally, op equals slash, which is the division operator. Put a colon, and then we can type print num1 divided by num2. And congratulations to everyone who has followed along, because you guys just built your own calculator. So now let's run this. So we can say, let's say 10, we want 10, and then we can say 15. And then we can hit enter, and let's say add 10 plus 15. So we're going to add 10 plus 15, and it returns 25. Now let's test out the subtraction operator. So let's say 10, 5, and we can subtract them, minus, and it says 5, because 10 minus 5 is 5. Let's test out the multiplication. So we can say 10 times 20, 20, then hit the asterisk, 200. That's correct. Now let's test out our last operator here. Hit enter. We can say 10 divided by, not there, 10, 2, then hit the slash, and it should give us 5. And it'll return a float, because every time you divide, it'll return a float. So that's conditionals and elif statements and else statements.
So now that you have learned about these conditional statements, we are now going to learn about chained conditionals. So let's first talk about what is a chained conditional. So a chained conditional is like where you have an if statement or elif statement, and you want to have two conditions to run a certain piece of code. So we can assign some variables, say x equals 11 and y equals 15. Okay? And then now let's get into the chained conditionals part. So we will get into a if statement here. So we can say if x is less than y, then we can run a certain amount of code here. We can say like print x is less than y. But let's say we want to only run a piece of code if x is less than y and y minus x equals 4. Then we would say and then now we would say y minus x equals 4. Here, like that. And since y minus x equals 4, then this would run. And here we're using the and keyword. So what that does is it'll only run the code inside the if statement if both conditions are true. And you can have as many conditions as you want. So you could have, you could add a couple more on, but you can have as much as you want. So that's the and operator. But let's say we want one of them to be true. So then we can say or, and then we could say if x is less than y, which is true, and y minus x equals 3, which is false. But the code will still run because we want only one of these conditions to be true. So the or operator will run the code if only one of the two or many operators is true. So let's run this. Let's say print true. True. You can save this and open up our terminal here. And then we can say tutorial6.py, hit enter, and it runs true because x is less than y, and that is one of the conditions that are true, and we only need one condition. And just like the and operator, it also can have as many conditions as you want. So now we are going to talk about the not keyword. So not. First, I want to I want you guys to guess what's going to happen. So I'll just run this here. And it does nothing. Because the not keyword wants both these conditions to be false. But one of them is true. So we say if x is greater than y, and save this, this should run here. And it runs true. So that's the basics of chained conditionals. So now that you've learned about chained conditionals, you're now going to learn about nested if statements. So a nested if statement is an if statement that has a condition here that is inside another if statement with a condition. So that means a nested if statement is an if statement that is inside an if statement. So how this works, we can set some variables. So we can say x equals 3 and y equals 4. And then let's just make an if statement and say if x is equals 3, then run this code. And then we can say print x is equal to 3. But now let's add in a nested if statement. So let's say if y equals 4, we can print x equals 3 and y equals 4. Let's save that and run that. So let's just give it a second here. Python 3, and we're gonna say tutorial 7.py. We hit enter, and then it prints x is equal to 3 and y is equal to 4. And how this code works is it'll run if x is equal to 3, and then it'll run if y is equal to 4. So it'll only run if y is equal to 4 if x is equal to 3. So let's just change x to 5 and save that. It doesn't print x is equal to 3 and y is equal to 4 because x is not equal to 3. So the if statement inside of the previous if statement won't run. And with nested if statements, you can nest as many if statements as you want. So you can put another if statement here and just keep on going. Now we can also add in an else statement here. So we can say else print x is equal to 3 and y is not equal to 4 here. So now we can save that and we can change this to 5, and then it should print that x is equal to 3 and y is not equal to 4. Let's run this, and it prints x is equal to 3 and y is not equal to 4. So we can also add in else statements and elifs. And also we can also add outside else, we can print x is not equal to 3 and save that. And then if we change x to like 2 and run the code, x is not equal to 3 because x is 2. So just to clarify that you can have as many nested if statements inside, and you can also add else and elif statements inside of a nested if statement. So now that you have mastered nested if statements, we are now going to move on to learning about for loops. So a for loop is basically a loop or a piece of code that goes over and over and loops over and over again. So first, let's get into the syntax. So the syntax for a for loop is for, and you can put any variable next, but I just prefer to use I here. And then you can do in range,
and tell it how many times to run. So we will just use 10 for now. And then a important piece is a colon, so that you can have code inside of the for loop. And now let's say we want to see I inside the loop. Then we can just print I. And let's save this and let's run it. So we can do Python 3 tutorial 8.py. And if we run this, let me expand this for you guys. Here, you see that there is only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's no 10, even though we have 10 up here. That's because the computer adds 1 every single time this loop runs, and it runs until I is 10. So we run this loop, and once I equals 10, the print statement doesn't run. So it doesn't print I is 10. So just to fix that, we can just change it to 11. And we can run this here. Give it a second. Oh, we need to save it first. Here. Now if we run it, it runs and it prints us 10. So to review, a for loop repeats over and over again and has a variable here that keeps on being added by 1, so that the variable's value increases by 1. And it runs until that variable reaches the number inside the range. And once that variable, this value, hits the number inside this range here, the code here won't run. So we can also use the for loop to skip numbers. So let's say we want to print every other number. We first have to add a 0 here to say that it starts at 0 and goes to 11. And then we can tell how many numbers we want to skip. So we put 2 here. And when we save this, we run it, and we get 0, 2, 4, 6, 8, and 10. That's because this value here tells the computer how many times we're going to add to I. So every time this loop runs, we're going to add 2 to I instead of 1. And we can put it to 5 here. Now when we run this here, it equals 0, 5, and 10 here. That's because I is plus 5 each time. It's basically saying I plus equals 5 every single time. So that's the basics of for loops. And I'm just going to clarify one more time and go in detail. For is the first word that you have to type in. It's a keyword. Then I is the variable. And then it's in range. And in range is really important. And then the range tells the computer how many times to run this. And you can put anything inside.
So now that you've got the hang of for loops, we're now going to move on to a different loop called the while loop.
Print the while loop has stopped here. And also up here we can print password. Let us run this. And when we run it, it asks us for the password. We'll just say stop. It prints stop, and it doesn't stop the while loop because we put a capital S. Now, if we type in stop without a capital S, the while loop has been stopped. So you can exit the while loop on a condition that you can put. So that's basically how while loops work, and I'll just give you one last overview. So basically, a while loop is where a loop runs over and over, and you can exit with a condition and using the break keyword, or you can have condition right in the while loop too. stop the loop from running. And the reason a while loop is used is because you can use a condition inside of it to break out of it, which means that the loop can be stopped at any time. So that's basically what while loops are.
So now that you've got the hang of while loops, we're now going to move on to a very useful data structure called lists.
So first, let's talk about what a list is. A list in Python is basically a data type, and a list data type can store multiple data types inside this one data type. So let's first talk about the syntax now. So the syntax for a list in Python is you first give the name of the list. We can just say color right here. Color equals, then we put 2 square brackets like this. That's the syntax. And then inside the square brackets, you put whatever different items you want inside the list. So you could just say blue. Then you have to separate each item with a comma. You can say green, and then you can say yellow. So this is a list with some colors inside of it. And you can also have multiple different data types inside. So you could technically have like the number 10 here, or true, which is a Boolean value. But for now, we'll just stick to only strings. So basically, a list in Python will be used to store multiple or lots of info or different data types inside this one list. So now let's talk about what we can do with a list. We can always add items to a list using the append function. So to add an item to the end of the list, you can type in the list name, which is colors, dot append, which will add an item to the end of the list. And inside the brackets, or parentheses in this case, you can put quotations or just a number or whatever item you want to append to the end of the list. So for now, we can just append red. And then we can then print our colors list. And we can also print it up here so we can see the difference. We'll print colors. Now down here, we can run the code here. And here, before, it's blue, green, yellow. And then now it's blue, green, yellow, red. Because the append function added red to the colors list. Now, let's say we want to remove a item from a list. Well, we have to use the pop function here. So basically, you're going to type colors or the name of the list dot pop. But before we get into the pop function, we have to talk about an important part about lists. They have something called indexing, which is basically a way of identifying each item in the list. So each item in a list has an index. And in computers, the first item always starts off with an index of 0 and then gradually increases. The second item will have an index of 1, and then the third item will have an index of 2, and so on. And you guys might be thinking, why don't computers start from 1? But this is just how computers work and process the information. So let's say we want to remove green. We will do colors.pop, put parentheses, and type in what index we want to remove. So green is the second item, and we can count 0 and then 1. So this is the first index. We can type 1, and once we save this and run this again, we can see that it's blue, green, yellow initially, which is our original list from up here. And then once we use the pop function, green is gone from this list. And then let's say you want to change the value of one item in the list. Let's say we want to change yellow to red instead of adding red or appending red. We can do colors, and instead of a dot, we're going to put square brackets and put the index of what item you want to change. So here, yellow is the third item or the second index here. So in those square brackets, we're going to type 2 or the second index in this case. And then we're going to put an equal sign and then type what thing you want to replace yellow with. And we can just say red. And now let's save this and run this again. And then you can see blue, green, yellow in the first thing that is printed. And then in the second thing that's printed, it's blue, green, red because we've changed yellow to red. So that's how you use lists in Python. And a good way to practice is basically write a program where you can take input from the user and then append it to the list. And then also you can use an if statement and say if the user types in a command to delete a specific item, you can ask the index of, like the user, the index of the item they want to delete and delete that item.
So once you've got the hang of lists, we're now going to move on to a similar data structure called tuples. So like in the previous tutorial, we learned about lists. And a list is basically a variable we can set, or like a name. Here we can say color is equal to the square brackets, and we put whatever items we want inside the list inside the square brackets. That's just the review. So now let's talk about tuples. Tuples are similar to lists. They're basically, you have a name of the tuple, and then you have the equal sign. But instead of square brackets, you put round brackets here. And like a list, we can put items inside of the round brackets. And they can also be of different data types. So here we could put blue. We can put a comma because we have to separate every item by a comma. We could also put red, and then we can put green here. We could also put like 3, 3.5, and like 4. But since this is a tuple about colors, we'll just stick to colors for now. And now we can save this, and we can also then print out color, and then we can run it here. So we can do Python 3 tutorial 11.py. And when we run this here, we should see it print out this tuple here. Let's give it a second. Should be loading. And there we go. Here we see that it printed out blue, comma red, comma green, which is our tuple. And let's say we want to access individual items here. We can also use indexing. So similar to lists, we would do color, put the square brackets, and let's say we want to get red. We'll put 1. And we'll save this, and we can run it again. And it prints out red. But one important thing about tuples is that you cannot change them. They're called immutable data types, which means you cannot change the data type or like change the stuff inside of this tuple. So that means you cannot add items or remove items or change items inside this tuple. Once you've got the hang of tuples, we're now going to move on to item iteration, which is a combination of for loops and lists. First, we're going to create a list to iterate through. We can just say list 1 here. And we can say list 1 is equal to, and you can put whatever you want. You can just say Python, comma, we'll say 5. You can say true, and then we can say 8.9. Now we have to create a for loop to iterate through list 1. So we can say for I in, and then we have to put our list here. So list 1. And we can put a colon, and then we can print or do whatever we want inside list 1. So we can just print we can just print I here because we're iterating through list 1. And I'm gonna go over this syntax here. So this is the for loop syntax, but then if we do for I in list 1, I will become the first variable the first time the loop runs. Then the loop runs again, and then I becomes the second variable, and so on. And it'll go through the whole list until I has become every item in the list. So we can save this, and then we can run this down below here. And it prints Python 5, true, and 8.9, which are the items of our list. We can also add conditionals. We can say if I is equal to 5, then we can print I. Then if that's not true, like if I, or if like I is equal to Python, which is not 5, we can say else print I is not 5. And we need to put quotations around this too. We can say I is not 5. And we can save this and then run it. So it'll say I is not 5 because Python's not 5. Then it'll say 5 because I is 5 and the second time the loop runs right here. And then the last 2 times it'll say I is not 5 here. So now let's talk about indexing. You can also use indexing in the conditionals. So we can say if list 1 I is equals to Python here, and put a colon, then print list 1 I. And then we can also do an else here, and then print I is not equal to Python. And then a key thing we have to do here is we have to change it from list 1, because we can't iterate through an item and index an item here. We have to put a numerical value. So basically what we have to do here is replace list 1 with range here, put range, and then here we have to put the len function, which is a function that will give you the length of a list here, or a tuple. So we can put len and then list 1. So it'll iterate here, and then we will run the for loop until list 1 is over. So once we run this, it'll say Python because the first item is Python, and then the last 3 items it'll say is not equal to Python because the last 3 variables are not equal to Python. Now that you've learned about item iteration, we are now going to move on and learn about string methods. So basically, what is a string method? A string method is basically a way of modifying, or like basically modifying a string to use it in a different way. So here I have written down all the methods here that we're going to be using in this video. So first we're going to talk about the dot strip method. So we're going to take some input from the user here. So we can say text is equal to input. We can just say input here. And we can print out text. And we can also print out text again. This time we can see the difference by using the dot strip method. Okay. Now once we run this here, it's going to ask us for some input down here in our terminal. So we can just say space, 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 hello, space, space. So basically what it's going to do is it's It's going to remove all the extra blank spaces in our text. So before, if we didn't have the dot strip, we would have a bunch of spaces before and after our hello. But using the dot strip method, we remove all those blank spaces. Now let's talk about what the len, or length, function does. This is not a method, so don't get these two confused. But this is a function. So basically what the function will do is it'll tell you the length of the string. So I'll just quickly comment this code out. And if you don't know how to comment out a code, commenting out a code is basically you put a hashtag in front of the line you want to comment out, and it won't run that piece of code. So here we can take out this dot strip here and put a len, or length, function around this. And once we run this again, you can type in 1, 2, 3, 4, 5 here, and it prints out the length of 5 because our string has a length of 5. Now let's talk about what the lower method does. You guys can probably already guess it, but here I'm going to go ahead and show you. I want to uncomment this code here, and we're going to write text dot lower and then put parentheses. And now let's save this and then run it. And now once we run it, we can type in like some capitals, and we can say hello world. And basically what it's going to do is it's going to remove all the uppercase letters and convert them into lowercase letters. And you guys can probably already guess what upper is going to do, but I'll show you guys here. So I'll save this and run it. Basically what upper is going to do is it's going to basically convert all the lowercase letters into uppercase. So here we typed in hello world, and now it becomes all caps hello world. Now the last method is the split method. This is probably the most useful out of all of them so far, and I use it a lot in my code. But basically what the dot split does is it's gonna split our string into a list based on what we want to split it by. So here we can put quotations here, and let's say we want to split it by a period. We can save this, and when we run it, we can say like hello dot world, and then it prints out a list of the string that we inputted, but it separates it by the period, which we have up here. So this is our before, which is hello dot world, and it splits it and removes the period because we're splitting it by the period. We could also do this for a space, and we can say this and run it. We can say input. We can say hello world. So hello space world. And when we hit enter, it'll remove the space and have hello as one item in a list and world as another item. So now that you've learned about a few string methods, we are now going to learn about the slice operator. So basically, what is the slice operator? The slice operator is basically an operator used to slice a string or a list. So let's give a list here. So we can say fruits, and then we could say apple, comma, pear, comma, strawberry, comma, blueberry. Let's save this. Now, you can easily get one of these items using indexing. But let's say you want to get pear and strawberry. Let's fix strawberry. So let's say you want to get pear and strawberry. So what you would have to do, I'll quickly show you the syntax first. You would have to put the list name here. And then you have the square brackets, and then this is the syntax. You have to put your starting index here, then a colon, and then you have to put your stop index, and then if you want, you can have a step. Let's say you want to go to the end of the list and have all the items till the end. You can leave the stop blank, or if you want it to start from the beginning, you can leave the start blank. And also, if you don't want to have a step, you can also leave the step blank. So let's say we want to get pear and strawberry. So pear is the second item, or index number 1. So we would say 1 colon, and then we want to get strawberry, which is the third item or the second index. But in indexing, the index or the number you put in is not included inside the indexing. So we would put, instead of 2, we would put 3 here. So now we can wrap this in a print statement here, and then save this, and then we can run it. It should print pear and strawberry here. It printed pear and strawberry down below in our terminal. We can also use this on strings. So let's say we want our text to be, hello, I like Python. And we can save this. Here, we also have to put an equals there. We can say text, our square brackets, and then let's say we want to get I like. So how indexing works in strings, you can use indexing in strings, by the way. So this would be our 0 index. This would be a 1. Here. So E would be our 1, then L would be 2, and then 3, 4, 5, 6, then 7, and then 8. So basically, let's say we want to get hello, right? We can just leave the start blank. So we could say colon, and we want to end here. So we would get 1, 2, 3, 4, 5. So we would want to put 5 here, even though this is the 4th index. And once we save this, it should print out hello, just like this. But let's say you want to get every other letter. Then you could put a colon here and have, let's say, 2. That'd be our step. Now once we run this, we would get HLO. We could also say we want it from the end of hello to the end of the string, basically. So what we would put here is, instead of 5, we would put 6 colon blank. And then now once we run this should go to till the end of the list, or I mean string in this case, and it does. It says I like Python. So now that you've got the hang of the slice operator, we are now going to learn about one of the most useful things in Python, which is functions. So basically, what is a function in Python? A function in Python is similar to a math function. And in a math function, you give an x value, and it does stuff to the x value and returns a y value. So that's similar to what you can do in Python. So the syntax for a function in Python is you have to write def to define the function here. And then you can put the name of the function. We can say add 2. And then we put parentheses. And inside the parentheses, we gotta pass our parameters, or basically what input we want to take. So here we can say x, and then put a colon here. And we want to add 2 to x. So we can say y equals x plus 2. And then finally, we gotta have an output. We need to return x to the program. So we are gonna type in return y. So now we have the y value here. So to basically run this function, you gotta call the function. So we can call it by putting the function name and then putting the parentheses and then putting what we want to pass in for x. So we can just say 9. And then we save this, and once we run this, it shouldn't do anything. The reason being is returning a value does not print that value. So if we want to print it, we can just wrap it in a print function, and then it should print 11. There we go. So you can do many more things with this. You can have a second function saying def. We can do subtract 2. And then we can put our parentheses, and then we can put our x, colon, and then inside we can say y is equal to x minus 2 here. And then we can return our y, and then you can run the subtract 2. So we can say subtract 2, and then we can pass in 9 again, and we can wrap this in a print function right here, and then this should give us 7. And there we go, it prints 7 down here. And also you can run the same function twice. So here I'm just going to comment this line of code out. We can run add 2 twice, and we can change this to 11. So here it should print 11 and then 13. There we go. So you can have as many functions as you want in any program, and you can call the function as many times as you want. So a good practice problem to solve using functions is you can try to make a calculator. And the parameters you could pass is you could pass a parameter of the first number, the second number, and then the operator, and then return the corresponding number based on the addition, subtraction, multiplication, or division. So that's just how you can practice this function in Python. So now that you've learned about functions in Python, we're now going to learn how to read a file. So first, we have to create a text file. So what you can do is you can hit the plus new file button, and then we can just name it file. And then the key thing to tell the computer that it's a text file is you have to add the .txt, and then you can hit enter. So we got a text file. So we can put some stuff inside of the text file. So we can say Python, we can say programming, and then we can say fun and easy. So we can save our text file now, and we can go back to our normal Python file that we have. And now we're gonna have to first tell the computer what file that we're gonna open. So we can say file equals open, and then we have to put parentheses, and then quotations, and then we have to put our file name. So here it is file.txt, and then we're gonna tell the computer we want to read from the text file. So we have to put a comma here, quotations, and then put an R for read. Now we gotta print this out. So here we can do f, which is just any variable you can choose, equals file dot read lines, and then put parentheses. And then now we need to print this out. So we can append everything to a list and print out the list. So here we can say new list, or we can say file list here. And we can make a blank list. And if you don't know how to use lists, you can go check out my lists video. I'll leave a link in the description down below. And then we can put for line in F, and then not quotations, but a colon. And then inside we will put new, or not new list, but file list dot append, and then we gotta put line dot strip. So we gotta strip because normally there'll be a \n, because in our text file here, when we hit enter, that's a new line. So we represent that as a \n. So now we need to print out our new list. So if we print, and then we can say not new list, but actually file list here, and we can save this. So now I'm going to explain our code. So basically here, we're going to open up our file here, and then this is going to read all the lines of our file. And then we're just creating an empty list to store everything from our, like every line from our file. And then we have a for loop that goes through all of our lines and appends them to the file list and takes away any \n or new line representation for Python. We can print out file list. So we should save this. And also, by the way, we need to save our text file here. And then when we run this, it prints out Python programming, fun and easy. So yeah, there is a harder way to do this, but this is the easiest way to read from a text file. So now that you've learned how to read a text file in Python, you're now going to move on and get a little bit more advanced and learn to write to a text file. So first, how do you write to a file in Python? I'm going to show you the syntax, but first we got to open our file. So we have file equals, and then we got to put open, and then parentheses, and then quotations, and put our file name. And we have a file from the previous video. I'm just going to be using that in today's video. And it has Python programming fun and easy. So I'm just going to be using this file. And then inside the open statement, we got to put in our file name, which is file.txt. And then in the last video, inside the second quotations, we put an R because we wanted to read the file. In this video, to write to a file, we got to put a W. And then to close the file, we have to do file.close and then put parentheses. So that's how you open and close the file. But how do you write to it? To write to it, you got to do file.write and then put parentheses. And then you got to put inside quotations whatever you want to write to it. So I'm just going to say, I'm learning how to write to a Python file. So basically this is going to write this inside the file.txt. So if we save this and then we run it, let's just give it a second. When we go to file.txt, it says, I'm learning how to write to a Python file. You guys are probably wondering, why did it clear the previous characters and words inside this file? So I will teach you how to write to a Python file in a different video without deleting the stuff inside the file already. But now I'm just going to show you how to write multiple lines inside this file using Python. So let's say we want to write a second line, but we can start from here. We can do file.write parentheses, quotations, and then we can just say Python is fun, and then exclamation marks, and then we can save this and we can run this really quick. And now when we go to our file, let's give it a second, there we go, it shows that these two sentences are on the same line. How to get around this is you got to put a \n here, and then put a \n here. So this will tell the computer that there's a new line. Now once we save this and run it, it should have a new line. So now we have two lines. Each sentence is on a different line. So once you've learned how to write to a text file, we're now gonna learn about some more string methods. So first, let's talk about the .find method. So first we have to create a string. So we can just create string equals, and let's say we can just say Python is fun to learn. And then now we got to use a dot find. And basically what the dot find is used for is you can basically find the indices of any character inside the string. So let's say we print string dot find. And now we can put in what character we want to find in our string. So let's say we want to find an O. Then we will put an O here and save this. Now when we run this, it should be print the indice of O. And here we have our first O at the fourth indice. This could be useful in many ways, like for a password. Let's say you want to have a password that has the letter O at the fourth indice, and only then it'll accept the password. So it'd be more of an unconventional type password system this could be used for. So now let's talk about the dot count method. So the dot count counts how many of the character there are in the string based on your given character. So we can use O in this example, and we can save this. Let's quickly run this, and there are two O's because the first one's right here, and the second one is right about here. So I'm just going to type some gibberish here. Quickly, just type some random letters. So if I just type some random letters, right? You can just say J right here and save this. And then this should print out how many J's there are. So there are 5 J's. Now let's see how we could use this in the real world. So now let's get into the project. So the project I'm going to do is I'm going to show you guys how to make a password, an unconventional password system. So we can have an input from the user first. So we can say string, or we'll say password equals input. Then we can put the quotations, and then we'll say password. And we'll ask them for their password. And now we can use an if statement. Say if password dot find, and then we can say, let's say p equals 4 for the fourth indice. We can put a colon. Then we can just say print you have a good password. And then we can use an else statement and say else print you have a wrong password. Now I'll save this and run it and see if it works. So we'll be asked for the password, and we want to have P as our fourth indice. So we can just say A, D, F, G, P, and then just gibberish after that, and hit enter. And it says you have a good password because our fifth letter or our fourth indice was P when that's what we typed in. And now let's test out if the wrong password system. We'll just run the program again and just type in gibberish. And when we enter, it says you have the wrong password. So now that you've got the hang of a few more string methods and expanded your library of string methods, we are now going to learn about modular programming. This is one of the most useful things in Python, and I use this in almost every application. So basically, modular programming is basically having separate files that have different functions in them and combining those files together into one program and running those functions. So what we use in Python is called libraries, which are basically a file with a bunch of functions on it. So we're going to be doing 2 examples today, one using the random library and one using the math library. They should come pre-installed with Python, So basically how you can use them is you need to import them to your file. So what you have to type in is import, and then we'll say random, which is the random library. And let's import the math one. And you do import math. So now we have both the libraries imported. Now we need to use the functions inside of them. So one of the functions inside the random library is random.randint, which is basically generating a random number between the specifications you give. So to use the function, we can first of all write random, which is our library name, and we need to write the library name so the file or like the computer knows which library we want to run the function from. Dot our function name, so we can say randint. And basically inside the randint function, we want to type in we can say the lowest number that's possible. So the minimum we could have as 1. And the maximum number randomly generated could be 10. So it'll randomly pick a number between 1 and 10. And we need to print this out. So we can write it in a print statement. Save this. And when we run this, it prints out 1. But next time we run it, it should print out a different number. Yep, it prints out 3. And if we run it one more time, it prints out 8, which is all just randomly generated numbers. Now we're just going to do another example of the math library. So one of the common functions you can use in the math library is to round a value up, right? So you can do math.ceil, which is how to round up a number using the math library. And we can put in any number that we want to round up. So we can say 3.2. Usually that would round down in normal math, but with the ceil function, it'll automatically round up. So we can wrap this in a print statement, save this, and then now when we run it, it prints out 4, because 3.2 rounded up to 4 using the ceil function. So yeah, that's mainly what you use the modular programming for, is importing different libraries and using them as functions, like using their functions inside your program. And you can even write your own libraries and publish them for other people to use. And the next video will be on object-oriented programming, which is slightly similar to functions, but it's a little bit more complicated. So now that you got the hang of modular programming, we're now going to move on to classes. So basically, what is a class? Because a class is basically a blueprint for objects and object-oriented programming. So we can create the class by saying class, and we can create the class parrot, for an example. And we have to put parentheses and a colon here. So we have created the class parrot. For now, we will put a pass here so it doesn't run or give us an error when we call or make an object for this class parrot. And now we want to make an object, which is basically going to have the attributes of class parrot. So we can say obj equals parrot, which is going to be our class, and parentheses. So we can save this, and when we run it, we have created our first object. So congratulations. Now let's create some functions and attributes for this class. So basically, classes have two main things: attributes and they have behaviors. Attributes are more like, let's say for the parrot, it's like what color is the parrot, and how tall is the parrot, and what kind of sound it makes. And some like behaviors would be that the parrot can fly. The parrot can copy human language or any language. And that too, parrots can fly into trees and they live in the forest. That would be another behavior. So we have to create attributes and behaviors for our parrot class. So we can just say we have to have our attributes defined by saying def, or defining a function. And this is a key function you have to define. You always have to define this type of function for defining attributes, which is underscore underscore init underscore underscore. And then you can put whatever parameters you want to pass. Here you have to always put self to call the class parrot. Then we can just say name of the parrot, and let's say the age. We can put colon here, and then inside we have to call the classes self, so that we do self dot name equals name, and then we do self dot age equals age. So now let's initiate like the parrot class again here. So we have object, and we can just say chirp here, chirp equals parrot. We can say self. We don't need to pass anything for self because that's a parameter defined by the class. We have to pass in the name and age parameters. So we can say name is chirp. Then we can say age is 5 years old. And let's say we want to print out the attributes. So we can print, and then we can say chirp is a, and this is a special format way of printing. And then to like fill in this brackets here, we're going to use the dot format. You can put parentheses here, which would be chirp dot underscore underscore class underscore underscore dot species. So that's basically what we would do here. And we can quickly have to define the species here, which I forgot to do. So we could say species is equal to bird here. We can just say that. We'll print this out. So if we run this, we have an error. Chirp is not defined. So our error is we forgot to put quotations here. So we save this and we can run it. And it says chirp is a bird. So ignore all of these dot format. That's just a way of printing it out. But we could just say chirp is a bird. Then to access some more information, we can print quote here. Let's put quotations, some brackets here, is years old. And then we're going to do the dot format again. So format, parentheses, oops. And then we can say chirp dot name, comma, chirp dot age. And we can save these. And when we run it, it says chirp is a bird from our previous print statement. And then it says chirp is 5 years old because it gets chirp.name from the self.name in the init function. And it gets chirp.age from self.age in the init function and fills them into these brackets. So that's basically the basics of classes. And if you get confused, you can always rewatch this video. And if you just wanted a review, just watch this in like 1.5 or 2 times speed. So now we're going to talk about creating methods. So I'm going to still use the same function, but I'm going to take away some of this code here so that it'll be simplified. We're still going to keep the core function of def in it, which is the attributes. And let's say we want our parrot to sing. So we can create def, or for a function, sing and we can do self and then song. Now we have to put a colon here, and then we can return or let's say here, we're going to use the format method again. Sings, another bracket, and then we're going to do dot format, and then we have to do self dot name from the init function, comma, song. So basically, it'll print out chirp here, which is the name of our parrot once if we create it as chirp, and then we will have the song, whatever song we give here. So we can save this, and then let's say our parrot can also dance. We can say def dance, then we have to do self, then a colon here, and we can return quotations, brackets, oops, is now dancing. Then we're going to use the dot format, and we'll do self dot name. And basically use the self to call attributes of an object in a class. And then what we can do is we need to initiate our object. So we can say chirp equals parrot. Let's name chirp as chirp. Chirp. Oh, right here. And let's give her or him the age of 9 this time. And then we can print chirp dot sing, and let's say we want him or her to sing happy. Just let's say the song name is happy because chirp is happy, and then we can print chirp dot dance and then save this. When we run this, it should run these functions inside the parrot class and print out chirp sings happy and chirp is now dancing. And that's exactly what happens here. It says chirp is sings happy and chirp is now dancing. Now, one final thing I'm going to teach you guys in this video, which will be very useful, is inheritance. So basically, this is like parent and child classes. It's like you have a parent class, which is a parent, and their child gets some of their attributes or some of their genes. Or let's say your parents have brown eyes. You might get brown eyes. Or you might get black eyes. It just has a chance. So this parent and child class, the child will inherit some of the parents' class attributes. So basically, I'm going to create the class bird here. Oop. Bird. And then colon. And then we can say the attributes is underscore underscore init underscore. Then we'll do self colon. And let's say print bird is ready. And then this is just an example. You probably wouldn't define an attribute as bird is ready, but we can, let's say some attributes. We'll just say, who is this? So function who is this? And then we'll take in self, and we can just say print bird. And then let's say this bird can swim. So def swim And then we can take in self again because we have to have self. And we'll print swim fast. And now we're gonna have a child class, or like a subclass. It's like a subclass of the class bird. So we can just say class penguin, and then to inherit the attributes of class bird, we need to put bird here so that it'll inherit some of the attributes and functions. So now we can create some attributes for this penguin class. We can say df underscore init underscore. And then here we're gonna call, we forgot this self here, so we need to do self. Now we have a colon. Now we're gonna call a super function, so which is super dot underscore init underscore. I'll talk more about super functions later in detail, but I'm just going to use this for this class. This is a little bit more advanced. And then we will print penguin is ready. Actually, I'll just talk about the super init, which is basically it'll inherit the attributes of the class bird. So that's why I use the super init function. And then we'll say df. We'll say who is this? Who is this? And then we need to take in self here. Self colon. And then we can say print penguin. And then we can say df run. And we can take in self again. And we can say run. We need to print here. And we can say run faster. And now when we create a penguin, let's say Peggy, just for fun, equals penguin, and then we do it here, and then we can say Peggy dot who is this, and then we can do Peggy dot swim. And the reason we can use the swim, even though we used the penguin class here and created an object inside the penguin class, is because since we inherited using the super function and we inherited the bird class, we can use all the bird class functions. So we'll put parentheses here, and then we can do Peggy dot run. Well, let's save this, and then we can run this really quick. We have a syntax error. I think I forgot to put a colon. Yep, I did. Save this, and now let's run it. So it says bird is ready, penguin is ready, because it inherits the object of bird is ready. And then it says penguin, like because it's who is this, which is a penguin. And basically this will override the other who is this function. Because when you have a parent and child class, you'll first of all prioritize the parent class, but then if you create a function with the same name as one of the functions in the parent class, the child class will override it and it'll take and run the function of the child class. And then when we do the swim function, it says swim faster. And when we do the run function, it says run faster. So that's basically parent and child classes. And this could be useful in many different situations. So now that you've learned about classes, We are now going to develop a real world application that you can use, which will web scrape Amazon prices. Basically, what web scraping is going onto the web using code and gathering information from websites that you want to gather information from. So today we will be gathering some prices of Amazon products. So first of all, I'm gonna import a few number of libraries. So first of all, we have to import requests, import requests, and then so that's basically one of the libraries to get like the HTML and the data from the website. And then we have to do do the import of the main library that we will be using, which is Beautiful Soup, which is basically going to be the library that does most of the web scraping. So we're going to do from BS4, which is Beautiful Soup, import Beautiful Soup. And then we're going to need one last library to parse the HTML, which means like go through the HTML and find out things that we need, which is LXML. So we can import LXML. So these are the libraries we need. And if you don't have them, you can always do pip3 install and then the library name. So that's how you get these libraries if you don't have them. Now we need to have a URL for the product that we want to look up so that our web scraper can find that URL and go into the web and scrape it from that specific URL. So I'm quickly just gonna pull up a product I have here, FIFA 21 on the Xbox One, and we can just copy the link here and then go back to Visual Studio, and we can put it in the save it in the URL equals, and then in quotations we can paste our URL. So here I have the URL for our FIFA 21 Xbox One video game. So we will just be using this as an example. You can use any URL that you'd like as long as it has a specific price and title and it's from Amazon, because I'm going to be teaching you how to do it for Amazon specifically for this one. And now we're going to have a dictionary here. This is going to be some useful information for our Beautiful Soup library to use and help find the data. So we're going to have something called headers equals, and this is a new thing you probably haven't learned. This is called a dictionary, where you can assign multiple values, and it's similar to a list, but with multiple variables being assigned values inside of it. So we have to have something called our user agent here. So user dash agent, and then a colon. That's how we're gonna assign the value. And basically our user agent, we can figure this out by going to Google and typing in my user agent, and basically copy this and come back to Visual Studio, and then in quotations paste it here. So that's our user agent. You shouldn't be using mine because that's my user agent. You should be using your own user agent so that your web scraper will work. And then we're also going to have to define the language that the web scraper is gonna accept or web scrape from. So we can just say accept dash language, and then colon, and then quotation mark. I'm going to be using English, and Amazon is the US Amazon is based off of English, so we're going to be using English here. And that's all we're going to do in this dictionary. And if this is confusing, don't worry, I will later on make a video about this. And now we have to actually go through all of the website's data, and if you don't know what HTML is, it's basically what they use to design the website and make the buttons and everything. So we have to figure out what's that the code that's making those buttons, everything, what's in the text, what's like the price, what's making the title for the name of the product. So we have to go through all of the HTML to figure that out. So we're going to say R is requests. This is where our requests library come in. And we're going to say dot get URL, comma, headers equals headers. So basically this is gonna go into our URL and get the URL to use later. And now we have to parse all of it, which it means like go through everything. This is the second part of this. We need to go through everything. So we have to do soup, we'll just name it soup, equals beautiful soup r.text. So this will read all the text from our website because the requests library here got all the text from our website and stored it in the variable r. Now we have to go look into the text here and parse through it and use the LXML library to do all of this. So this is also going through all of our text here. And now we need to find the name of this product. So we can say name is equal to soup dot select and underscore 1. So we have to select 1. And then we're going to use the selector function equals quotations. So basically what this is we have to either put in the ID or a class of this product. If you don't know what that is, that's basically an identification system in HTML, which will basically say like the ID of this tag or this line of code is, let's say, product name, so that later when you have to like change the color of the text there, you can use the product name instead of trying to find the specific tag in the HTML. So we're gonna find the specific tag for our product here for the name, and to basically get into the inspection to view the HTML, we have to double tap and hit inspect here. And if you're on a Mac, you can use F12, and basically we can highlight our name here, and let's actually inspect like that. We'll highlight it and inspect, and we see FIFA 21 Xbox One, right? And now we need to find the ID here. So we see ID is equal to product title. So we can copy that and get the product title. So this is the HTML ID here that would be used for other things in the HTML. And this helps us easily identify the name of this product here. So now let's go back to our Visual Studio and paste that in. But before we paste that in, since we're having an ID here, to let soup know that this is an ID, we have to put in a hashtag here, specifying that this name is an ID. So we will paste our ID in here. And we don't want all of those spaces that we saw around the FIFA 21 here. There's a lot of spaces everywhere. So to get rid of that, we're just going to use .get text. So this will get only the text from that HTML. Now we're going to use the name equals name.strip. This is basically stripping it of anything unnecessary. And then we can print out name. Now, let's say we want to get the price of this, right? Then we can just do price is equal to soup dot select underscore 1, and then we have to use our selector thing again. So we can say selector equals quotation marks, and then we can go back to our Chrome tab and exit this inspect one for the title, and now let it load. We gotta inspect our price here. So highlight the price and then inspect. Let's give it a second, and there we go. It says the span ID equals price block our price. That's its ID here. So we can now come back to Visual Studio Code after copying it, and once again put the hashtag there, paste this, and now we should have the correct ID for our price, and we can print price. And if there is no errors, this should work here. You can run this. Let's let it run. And we have invalid syntax. Let's quickly go to our dictionary, and yep, I missed adding a comma here. You have to add a comma to let the like Python know that there's another variable being assigned. And so that should have fixed our problem by adding that comma there. So now let's run it again. Let's give it a second here. And there we go. It prints out FIFA 21 Xbox One. And then it says a span price block, our price, $24.99. And that's because we forgot to put our get text here. That should solve that problem. And then when we run this should work here. There we go. It says FIFA 21 Xbox One, $24.99. And we can verify by going back to our link, and there we go. It says $24.99 and FIFA 21 Xbox One. So now that you've learned how to web scrape and build a real-world application in Python, you can now call yourself a Python developer. So I would like to say thank you for watching, and please subscribe, and it only takes you 2 seconds, and it helps out the channel a lot. And if you learned a lot from this video or course, please hit the like button. And I'll see you in the next one. Later.